Yeah, there we go.
Okay.
All right.
That's better.
Try that again.
Yeah, take 3. So, can you all hear us? I assume they can. Because we're seeing like 1 bar on the Wi-Fi. We're at Dev 2 Next.
Mm-hmm.
It's the first instance of the show, and the first successful one that got off the
Right,
ground.
because you tried to do it, and then COVID happened, and that killed it.
That was a bad year
Yeah.
for lots of reasons.
Oh yeah.
And then so anyway, yeah, it's the first one. It's the first one. I can't believe it. We're actually here, and I think it's a rousing success. It looks like people are having a good time.
Yeah.
It's run by our friend Dr. Venkat Subramaniam, who is video is a bit laggy, but audio is fine. Oh dear.
Should we switch to audio?
No, I mean I want.
No.
I mean as long as it's being recorded. Yeah.
Okay.
Okay. Anyway, all that to say, it's being run by our friend Dr. Subramaniam, who, when he calls for people to join him at his conference, people show up. There are people from all over.
Yeah, a lot of people have come from Europe.
Deep bench too. These are not like save for myself, of course. These are not B tier speakers. These are like some of the. You'd be lucky to have a quarter of these in one place, and they're all here. Like just all of them. It's amazing. And of course, one of my all-time Double Dutch favorite speakers and technologists and authors and teachers and educators is you, Bruce.
Well, thank you.
Bruce Eckel. Have you? I bet people in the audience will have read your many books and your writing.
Hard to say.
Yeah.
There's some that were educational for me, but didn't necessarily get out. Like James Warden and I co-authored the book, and as soon as we were done, so this was back when Steve Jobs said, we're not going to use Flash anymore. It was like right after the book came out, but still, it was a good experience, and we learned things.
It's got a great cover too. And
yes, it's a nice cover. First steps in Flex, but it's Flex is not really a thing anymore.
Which is a shame.
Flash, that was interesting stuff.
I was all in on it because we had a technology called Spring BlazeDS.
Oh yeah.
So BlazeDS is the infrastructure that Adobe had put out that I think they made open source. If memory serves, and basically you give it an object, it'll turn it into a service that you can invoke via AMF, the action script message format, right? And so it's like RPC, which it's not great, but it was very convenient. And we built an adapter layer so that you could just take a Spring Bean, any object managed by Spring, and that could be run through this BlazeDS integration. So we call that project Spring BlazeDS. I spoke at Adobe Max.
Yeah.
Like it's not you would not expect to find me at Adobe Max.
Was this the one in Las Vegas?
This is Los Angeles back then. But this is like 14 years ago, But all because I'm a big fan of that stuff. So when we were out there talking about Spring BlazeDS and Flex and all that, I was like, yeah, sign me up. And then Steve Jobs.
Yeah.
Yeah.
Well, and I understand why.
Sure. Yeah.
The phones were and their batteries sucked dry.
Yeah.
It was ultimately Adobe's fault for not making it efficient.
Yeah. Yeah, it's true. It's true. But I think now the phones are. I mean, the phones have. Some of these phones now have, like the new Google phones, I noticed, have more RAM at 16 gigs than some of Apple's cheapest laptop configurations. These things are like,
I know, amazing. The
streams are crossing, they're converging and crossing. Okay, so that was first steps in Flex. Let's do a little bit of a walk through the history here, because I have so many questions. What was your first book?
My first book, I had been writing for a magazine that was published out of Bend, Oregon, called Microcornucopia. And very few people will probably remember it, but it was I loved everybody who worked on it, and we had these little conferences. Yes.
You ever been
to Bend?
Yeah.
Oh, I spent a lot of time in Bend.
Oh, in the Seventh Mountain? You know that?
I know. I don't know if I ever stayed there, but I know of it. Well, I had a friend who had a house there, so we would typically stay with him. And
it's paradise. It was high desert. It's so good.
Yeah, it was a funky little magazine, but at the time, it just had a really nice, cool factor.
Yeah.
But I wrote a bunch of articles, and then I combined them into a book called "Computer Interfacing with Pascal and C." So, and it was basically how to kind of open your mostly K-Pros, but then it evolved into the early IBM PC clones. And you'd open them up and you'd go in and butz around with them or connect to the parallel port and make LEDs turn on and off and make stepper motors turn around and all kinds of stuff like that.
They were part of the maker movement.
It was. It wasn't really I mean, all of microcornucopia was kind of that. There wasn't a real separation. But and so I self-published that one, and it was very satisfying.
Yeah.
But then I did. Then I got into C++, and I wrote.
When does not simply get into C++? Like, what happened?
Well, I started working at the University of Washington in the School of Oceanography, and the professor who had gotten the grant, what he wanted to do was make programming more accessible to scientists and engineers, and the goal was to be able to take like an equation and sort of directly translate it into code so that they didn't have to deal with Fortran and stuff like that. And so object-oriented programming was kind of appealing that way. Mostly you could create, say, matrix objects, and you could overload the operator star and do a vector times a matrix, that kind of thing, which is like common now, but at the time that would have been sort of revolutionary. And we looked at, we considered using Objective-C, and then we decided to we chose C++ for, I don't remember what, but at the time, to get the compiler, we had to actually contact AT&T. And as far as I know, Bjarne himself may have mailed us this like tape,
Right.
And so we had to put it on the thing. And what you got was the basically the preprocessor. So you had to have a C compiler, and this would translate C++ into C, which turns out was pretty helpful because I could look at the C code and go, oh, I see, there's this this is what a virtual function does.
Right.
It's doing this weird little dance so that, you don't have to, it's basically doing type check coding for you. And so that's kind of how I figured it out, because there wasn't really any books or anything at the time. And then I started writing articles about it for various magazines. And then some publisher approached me and said, do you want to write a book? It was, what was it? Osborne McGraw-Hill.
Oh, right. Time.
Okay. Yeah. And so that was using C++. And then I wrote another one called C++ Inside and Out. Neither of those are really worth looking at.
Okay.
But I joined the C++ Standards Committee at some point there. And
is this the 80s at this point, or?
Yes, it's the 80s. And we went to, my professor and I went, so this guy ended up creating the, what was that library called? Rogue Wave. He created the Rogue Wave library, which for a while was popular, and he turned it into a company, and I think they even went public or something.
Good for them.
Yes. But we went to a conference in New Orleans, and I was sitting at a table with Tom Keffer and somebody else, and this guy with kind of a odd accent is sitting with us, and it slowly dawned on me, this is Bjarne Stroustrup, and so I got to know him that way. And when I was living back east, they had the inaugural meeting in Washington, D.C., so I went down to it, and I think he had seen my books or whatever. Anyway, knew it was he, and he kind of explicitly said, you should be on the committee. And it was
when Bjarne invites you.
Sure, why not? Well, and I looked at it and I thought, here are the smartest people about this language.
Yeah.
And so where else am I going to learn? And when I would go to the meetings, I would have accumulated a bunch of questions, And usually in the first day, I could go around and ask people, what about this?
Yeah.
What about, and I would have the questions answered. So I figured, well, this is better than getting, a graduate degree or something, or another graduate degree in my case. And I thought, yeah, this is a good way to spend my time. But yes.
Wait, actually, that's a good point. I should have started a little bit earlier than that, I guess. You got into the Fortran and C++ and all that. So what got you to computers in the first place? Let's go back even further here.
Let's see. I was a sophomore. I think I was a sophomore in high school, and I had a math class from someone who had been an engineer. This was in San Diego. He had been an engineer, and he was a terrible math teacher, but he was really into computers. And we had one of these old ASR 33 teletypes with the punch tape and the acoustic coupler that you could whistle at, and it would listen to you. And I think it was 110 baud, something like that. And it was hooking. We were able to use the, I think it was an HP 1000 that we never saw. It was in a closet someplace. It was all through the phone coupler, but we could program in BASIC. And, like some early primitive form of BASIC, and it was fascinating. So that's mostly what I remember about that class. But then I didn't touch computers again until sometime in college. And this was just sort of mostly side things. And I would maybe take classes if I could. And
it was a means to an end for maths or for some other.
No, I was just interested in it.
Okay.
Yeah.
Okay.
Yeah. So and then I kept going, but I initially was a journalism major, and then for a year, and then I changed to physics, and then towards the end of that, I was able to take some engineering classes for technical breadth or whatever, and it was like, oh, I wasn't a very good physics student, but after all the math that I've had, you drop into engineering, and it's like,
breath of fresh air.
Yeah, the engineers, they would immediately grab their calculators and start putting numbers in.
Yeah.
But you just go, well, we could do some algebra on this thing. And then the answer is A over B, and I don't even have to get a calculator to get the answer. And it was like, okay, so engineering is easy once you have a
superpower,
strong background in it's only in the last 15 or 20 years that I actually began to understand things that I should have understood in physics.
Oh, really?
Well, just like, what is science at all? Like, I didn't understand that. It was just like, oh, this is this. It just understanding, oh, we're creating models, and a model has to fit the data, and it has to be predictive.
Sure.
And if it isn't, we tweak the model. Whereas when I was a student, they would write an equation, say that equal sign there, an equation, and then which was just, they knew it was a model, and they go, oh, well, this is a small factor, so we could throw it away. And that stumped me. That stopped me, because I'm going, this is an equation. You can't throw pieces of an equation away. That's not how that works. And so I couldn't get beyond that. But then once I finally understood that, and I think it was actually early experiments with AI that made me realize, oh, AI is just a model.
Yeah.
And it fits these. Oh, that's what we do with science. And so I started, some of those pieces started, if I'd understood that, if that would have been the first thing that they said, is just creating models.
Yeah.
Here's how models work. And they're not perfect.
Right.
They're not exact. And
they're not final either.
They're not final if we discover the model doesn't work. This is why, say, Einstein with his, one of the things he showed, he explained the precession of Mercury, because people are going, well, according to Newtonian physics, it shouldn't do that. And Einstein said, well, yes, but with general relativity, we can show that actually, I can show that I can predict it. And
what a nice feeling it must be to arrive upon a solution that is so obviously useful and self-evidently useful that it solves other outstanding problems for people as just a knock-on effect.
Mm-hmm.
Because I'm sure he wasn't trying to solve that. It was just a thing that got
Well,
solving
that might have
theory or
been.
something.
I'm not sure if that was. I think that was one of the ways he proved.
Yeah.
He was going, yeah, this is because that was a sore thumb for cosmologists.
Okay.
So anyway, finally started, in the later years of my life, finally go, oh, that's what that was about. That would have been interesting to have been able to know that when I was a student.
But I feel very bad for people like myself and others listening to you, because if your life is one where you've got regrets about the approach and path you took, and the sort of paths that were untaken, and that's with a life as awesome as yours and all the accomplishments of yours, what hope that the rest of us have,
Well, so the person who designs my book covers,
Daniel Will Harris.
yes, I've known him. We met when we were 10 years old.
Oh.
So we've known each other for a really long time. And so we have these conversations because we've gone through this arc of life. And every once in a while, it's like, oh, I figured out this thing that is really basic, and it's taken this many years. What hope have we of making advancements in life if it takes this long to figure out something so basic?
This is, by the way, what is one of the things that's most endearing about you is all your books are sort of hey, I learned a new thing that may or may not invalidate what I talked about before, and you're the first to say, hey, it's different now. Let's talk about this other thing I learned. And I just love somebody who's rigorously committed to just always going forward, even if it meant that the paths taken before were somewhat invalidated or maybe
sort of like objects.
Sure. Yeah.
Yeah, we went way overboard on objects, and it took me such a long time to really kind of dissect that and figure it out. And there were people who were, writing, oh, objects were, a mistake or whatever. And it's like, well, maybe not a full mistake, but sure, we went way too deep into objects.
I mean, I remember in the 90s when, do you remember you could buy word processing software? Like I remember
WordStar.
But I mean, one of them actually had was it Coral Word Perfect or was it Borland Word? But I think at one point they embarked upon a Java port, and they were advertising. It's like, oh look, now object oriented, as though the average user, actual cares,
right.
Nobody cares.
I know, that's how distant we get.
Yeah. Anyway, okay, so fast forwarding just a wee bit here again.
Mm-hmm.
So you're in the C++ standards body.
Mm-hmm. For 7 or 8 years. Yeah.
At this point, did you start to, when did you write thinking in C++? And
so
why?
that was my
already had 2 books.
third book. Well, it was, I kept learning about things and kept wanting to make them better. And I think one of there were a lot of books, maybe it's still true, I don't know, but there were a lot of books where people were churning them out so fast.
Yeah.
And so you could pick up a book and just kind of open it anywhere and look at the code and go, well, that's a bug, because they wouldn't actually test their code before they'd paste it into the book.
Right.
Because they were just trying to get this thing out. And anybody who works on a book knows that, you have these ideas. Everything's going to be wonderful. And then there's this part between starting and wonderful where you actually have to create the book. And if you're not into that, if that's not an enjoyable experience, boy, it's really hard to get across that bridge. And I like that process, and I'm not looking at it going, look how many hours I've put in on this and will it pay off?
Right.
Because sometimes it doesn't. And if your interest is in, having written a book,
right,
then that's not a good sign.
No.
If you're interested in the process of writing a book, then it's much more satisfying. And I don't know, that's the way it is for me.
Well, so I've written 7. They're not good.
Wow.
1 was okay, not good. And each time I swear I'm never going to do it again. Each time I swear this is the last one.
Mm-hmm.
And then
but something sucks you back in.
like the Mafia. You can just get pulled back into the gravity of it. And in the last one, to make it, because like what you just said is, if you don't enjoy it, you're not going to do it. And that's true for everything, right? If you don't enjoy the software you're writing, you're not going to do a particularly committed, sort of fully throated.
Yeah, you might do it, but you just hack it out.
You just
and
want to
then
be done with it.
Then
right?
you're going to be disappointed with the results.
Always. And so in the last one, I went self-publishing.
Mhm.
I built a pipeline
Ah,
so that, and I learned, obviously, I think we talked about this last night. I was always impressed how more than 20 years ago, you were talking about how you had built a system
to automate the
extracting the
testing,
code and then compiling it and running it.
and then putting it in a place where people could use
Right.
it. And,
So you kept the code for your examples in the book itself, but then you extracted them out into source files. Whereas now I think my approach is, it's a separate source file, but I include them in the book.
I think the next book will be that way too. Yeah,
It's
because well, the tooling is so much better, and
Right.
you've got all your testing and all that kind of stuff, and then you automatically include it.
Yeah.
And I mean, I've done both ways.
Yeah.
So.
Well, I mean, but my point is, you built JUnit before JUnit. Basically, you had
Mhm.
an automatic system, which is, I mean, it's not controversial now to suggest you should have an automatic harness of tests and whatever surrounding your code. But when you wrote that book, JUnit wasn't a thing yet. I mean,
No.
that's how new that was,
No.
So so you wrote that. So you wrote the thinking in C++. Like, what was what about, by this point, first of all, was the compiler giving you? There was no more intermediate C, right?
Oh yeah. I think yes. I'm pretty sure. I can't remember, but I'm pretty sure the compiler was more. Yeah. No, CFront went away.
Okay.
Yeah.
Sure.
That was just kind of their initial way of getting it out there.
I've never used C++ with a C. But,
No, it was really because to make it cross-platform,
Sure.
you had to rely on, and the thing is, there was no ANSI standard C at the time, and so the CFront had to accommodate these different C++ or C compilers, but it was a way, it was kind of the initial idea of write once, run everywhere,
Right.
but instead of the JVM, you had the C compiler, so it was pretty brilliant.
Yeah, sure.
In many ways, but
And it was purpose built to take advantage of the best features of each. I mean, if you have a compiler specifically for Windows versus Mac, maybe there's some insight in that compiler that optimizes for that platform,
Right.
that we don't actually have in Java, right? Java
Mhm.
doesn't give you the maximal output on each platform. By definition, it's meant to be the abstracted sort of lowest common denominator.
Mhm.
So you were thinking in C++. Why was that the book that broke through? Because that's the first book I ever found. It feels like that's the book that was like, before thinking in Java, I think most people would have found you for that book,
Well, I would say I had enough practice with the earlier books that I got a sense of.
How to tell a story.
Yeah, I would think so. I would think so. Voice. You find your voice. That's probably the hardest thing for any person to do.
Yeah.
To first of all know that that's what you're seeking,
Right.
and then to actually find
Cultivate
it.
it.
Yeah. Just go, oh yeah, this feels. I think I've always imagined an audience, and it's not a conscious thing. It's just a sense of I'm speaking to an audience when I write.
Right.
And I'm imagining that audience out there. It's just the way I think.
And speaking of the audience,
Mhm.
we've gotten some nice comments here. This is
Okay.
Hi from Northern Spain. Thinking in Java was my first Java book.
Oh, nice.
Yeah. It's certainly the first Java book that I cared for, and I still care for.
Mhm.
Thank you, Josh, for interviewing Bruce, a legend and thought leader. Can anyways say, I think they mean we stand on the shoulders of giants when we
I get it.
work with you. And of course, Bruce, thanks for thinking in Java and C++.
Nice.
25 years ago.
Yeah, long time.
It's been a minute, yeah.
And it's been quite a while. Yeah.
A little anecdote, folks. I mean, if you had the second edition of the book, my name is there in the cover in the comments.
Right.
I'm such a big fan. I mean,
Yeah. No, I think I remember. Yeah.
Vaguely.
We had several pages
Right.
of people writing in. I thought, I should put these.
I really appreciate
these
it.
in. Yeah.
It was a great book then. It's still a great
Uh-huh.
book. I tell people if they can lay hands on a copy of it, it's
Mhm.
it's a good read for the fundamentals. And the reason it's a good read for the fundamentals is not because it's a prosaic description of the syntax of the language, but because it speaks, as you say, with your voice and tells a story. And that story, I always thought was very interesting because it meant that I could come at a feature, not just for the how, but for the why, right? With your
Right,
text.
right. Yeah. Well, and I was not like a huge fan of Java. I would dissect it.
Yeah,
and,
you did.
and I went at it with kind of, I mean, I guess a critical eye, and there were a lot of features that I didn't like, and over the years I had struggles with it. Like, I mean, I don't know how much you tried to do with concurrency early on, and it's like you're going, I feel like I'm doing everything right, and yet it's doing these weird things. And of course they were going, no, we're everything's fine, we're doing it all right. And then years later we discover, nope, it was screwed up always from day one.
Oh, the double locking problem. This is, people don't remember, there up until Java 5, there was a situation where you could get a invalid state in concurrency and it was unfixable, but for the code in the JVM itself.
Yeah.
There's nothing you could do or in Java to get a consistent result. And it was like, it was prescribed incorrectly in the Java language spec, like, it took him, that was Java 5,
and
a decade later.
Think about the features that got deprecated finally after
finalizers.
So long. Yes, finalizers, but also a lot of the basic concurrency primitives. They finally just said, yep, this has always been wrong. We're deprecating these.
Use runnable, not thread.
They never really fully, I mean, I think they should have apologized for that because of the amount of time that we struggled and going, I feel like I'm doing it right, but it's concurrency, so who knows? And then it turned out, no, it was always screwed up. It was always a problem. And so there, I have these resentments.
Oh dear.
I mean, I learned a lot, of course, but if I'd have known I was fighting with an impossible problem, it would have been
a time saver too.
And I would have said, okay, look, this is broken, don't do it. But I couldn't determine it, and all the docs were saying, nope, it's all fine.
Tony Hoare, right? He talked about how even in the 70s, he talked about how when he's talking about CSP, communicating sequential processes, even he talked about how threads weren't a particularly safe model on which to build a concurrent or parallel system. And then of course, my running line for most of my talks is there's only one person who truly knows how to write safe multi-threaded job code, and it's not you. I don't know who it is, but it's not you. It's not me. So don't do it. Use something higher.
It's probably Brian Getz, but
if there's anybody, it's probably he's the one I think of, right? But concurrency in practice, but even there,
I saw he did a presentation years ago, which it's really unfortunate that it didn't get recorded, but he talked about how it's basically impossible to use locks and threads and get it right.
Yeah.
And it's really a matter of scaling. And that's the thing. People go, oh, if I can do it in the small, then it'll scale. But it doesn't scale. And he made a really clear case for that. And it was like, I walked out of that and go, okay, it's not just me. No. It really is pretty much impossible to do.
Brian, I love people like him and Mark Reynolds and all that who have been committed to the effort, to the project of Java for decades, but there's a lot of people, they're also relatively new, even though they've been there for decades, because the cast of people that worked on Java from day one, a lot of those people have shuffled off, they're retired, they're doing whatever. So the new blood, including Brian Getz and all that, they've you've seen virtual threads, right? That's a marvel of engineering. I could not believe they managed to release that. What a coup, I give them a lot of credit for undoing the wrongs.
Especially because what they inherited and the backwards compatibility guarantee is so
incredible.
And so it's like, okay, I don't really love the language. I hope that I never have to go back to it again. But I acknowledge that what he and that team are doing is like, oh man, I sure wouldn't want to have to fight with that mess. And they're able to do it. So
and we benefit because nowadays a little foreshadowing here, but you've also got Kotlin and Scala books, which all benefit. It redounds to the benefit that the JVM is getting better and better every day.
Oh yeah,
every 6 months.
Yeah, it's kind of a universal thing. One of the things that's happening in the world of concurrency is that the version of Python that is just being released
The
right now.
GILs deprecated.
No. It is not deprecated.
Oh, but it's
You can build a
Right.
version of it that has the GIL turned off,
Right.
but the people in the know are saying, okay, fine, go ahead and try it, but you're dealing with free threading, and we're back to this problem of nobody can get that right. And it's like, so the one that you download still has the GIL because
backwards.
it solves an important problem, but people have just been trying to fight with it. And I think what they're going to find is that it's still an intractable problem.
Right.
It's not so anyway, but the folks who have been saying no, we really need the GIL, saying fine, you want to give this a try, go ahead, but don't make it part of the mainstream Python, because that's going to break everything.
Right.
Yeah. So
What's that distribution of Python? Something less.
Stackless.
Stackless.
That was another
separate-
attempt to do that. Yeah, and I don't
with
think
some heavy caveats. Like
yes,
it's not
yes.
it's not everything that's going to work.
Well, right, and the thing is, you've got all these existing libraries that depend on it and are built around that model, and those aren't going to work. And so this idea is like, oh well, I mean, this is worse than Python 2 to 3 by far, because it would require all those things to be rewritten so that they are compatible with this. And I think what we're going to find out is like, no, it doesn't work. You can't do it.
I think actually it's okay. So Python did, I think where you're doing CPU bound work, then of course you want to be able to leverage every core and do things at the same time. But that's not most services, right? Most of it is IO bound, and to the extent that Python now has async await and has generators and the ability to yield, and I'm not blocking the thread. Then
I'll tell you what's the biggest I think performance benefit is the seamless connection to Rust.
Yeah.
Because I have tried using all of the other things for writing compiled modules to work with Python. I could never get it. I couldn't not figure them out.
Yeah.
And B, when I did figure them out, they wouldn't work right. Rust, on the other hand, is like, so you profile your program. Right. You find the part that is your bottleneck, and you can quite easily use the AI, and it will walk you through everything. And it'll say, I want this function to be in Rust. Mm-hmm. And then you get something where you import the module. You can't even tell it's written in Rust, except that it's running lightning fast.
Seamless,
and you can do your parallelism and everything if you want to do it there. Or maybe not. Maybe that's all you need to do is rewrite that, and things are running fast.
Yeah.
So it's that, I think, is the thing
Huge.
that is really giant.
It's fun that you say that, because the message, what you just said, is basically prototype it in Python, and if you need to stub out to some faster language for the performant bits,
just
Python,
a little bit.
Just a little bit.
Yeah.
And I remember, so you've been on a Python kick for the last 20 plus years, and I really appreciate it.
25 to 30.
25, yeah. Like one of the OGs, right? I mean, obviously Python's a fair bit older than Java even, but you got into it. I remember reading your writings. I mean, even that system that we just discussed that extracts the text and automates and validates it.
The build system, that was one of the first things that I did with it.
In Python, yeah.
Yeah.
It was
I had originally written it in C++, and it took me, over 2 weeks, and then I rewrote it. And once I saw the value of Python, I rewrote it in half a day.
And that's with now some will say, well, that's because you knew the domain.
This is a factor,
Can't discount that.
No.
But you were also an expert C++ programmer, and it still took you 2 weeks.
Oh, yeah.
And you were a fairly debutante Python programmer at that point.
Certainly, yeah.
By comparison.
That's true. Yeah, I'd say those things balance themselves out. And so you could look at it and say, yeah, you're about, 20 times more productive. And, but then, like, I would say, when you compare Rust to C++, then
when's way more fun?
I would just say, if we had Rust, C++ wouldn't have happened.
Right.
I mean, there's so many advances in it, including, yes, they have object-like things, but they don't have direct support for inheritance,
Right.
which is where probably we fell down, is getting lost in inheritance. Whereas a data structure that has some kind of built-in type
Right.
support and everything, that's great. Just don't go crazy with it like we did with, everything's got to be an object, and you got to have these deep inheritance hierarchies, all this stuff that turned out to be not a great idea. And like the Liskov substitution principle really doesn't apply to compiled languages. It was really, if you look at Smalltalk is like incredibly dynamic.
Yeah.
And you take that and you go, well, we'll just move that to a static language. And it's like, that translation there's a bunch of things that get lost there.
Because you have no runtime. You need that runtime to make that dynamic stuff.
Yes.
And I kind of wonder, Objective-C is a compiled language that has message passing as opposed to message method invocation, right? It is, you send a message to an object just like in Smalltalk.
Right.
But I kind of wonder, there must be an overhead. They must have a runtime, in fact, basically. And I don't. Yeah. Okay.
Yeah.
Well, let me. So
move on.
Let's talk. No,
Okay.
definitely not move on. I love Python.
Okay.
I talk about Python a lot, and I love Python. And I'm a big fan. So what? Like at the time, Ruby was already. I remember reading a Dr. Dobbs article from Matsumura, from Mats in 1998. I think it was like. He had an article about Ruby, this programming language called Ruby, in Dr. Dobbs, and I read. And Python was obviously starting to become prolific. There's NASA, Google, ILM, all these companies doing interesting things with it. But of course, PHP was also there at the time, right? Eckel and Perl were also known quantities. Why Python at the time? Why would you embark upon that journey?
Well, my first dynamic language was, if you don't count BASIC, I guess, was Perl.
Oh yeah.
And it was like, oh wow, I can write this code and it just executes immediately. I don't have to go through all these elaborate compile steps. Oh, this is great. And then 2 weeks later, I looked at the code that I wrote. What does this do? And it's the idea of write only code. And so that put me off of that. And then when I didn't know about Python when I was doing this, it was just an early experiment. And then when I looked at Python, it was, this is readable to me. And I think Guido was always focused on focused on the people, and the reason that the Python community is so welcoming for everybody is because he always, that was his highest goal, was to make it something that everybody could connect with.
Even his ABC work.
Yeah.
That was he did a language that helped people learn programming, right? Like before did Python.
Sure.
And so you can see that in every nook and cranny of Python is sort of accessible first. It's meant to be apparent.
And the group that he built around him all had those same ideals.
So true.
And I spent some time with them way back when, and every one of those people is just they just have that shared ideal of, we want to include everybody. We don't want to exclude people. And unfortunately, things like the functional programming world has a terrible reputation in terms. I don't know if you've had this experience, but when I was trying to write the Scala book,
oh dear,
I accidentally wandered into some sort of chat room.
Oh no!
And they, and it was like immediate yelling, and I just kind of slowly backed out of that room, and it was like, and so many people have had that experience, and so it has driven a lot of people away from it. It's really too bad. So that's one of the reasons why we wanted to write the effect-oriented programming book, was to kind of fill in that, make it friendlier for people.
Let's talk about that in a second.
Yes,
we will come back.
No, that's fine.
Then save the best, literally the best for last. So the community is everything. I completely agree with it.
Oh, right. That's what you tried to do with Spring.
Yeah, we tried to do that. It's welcoming. We want it to be welcoming. It starts from the top. The guy who started it, Rod, Johnson.
Sure, I remember. Yeah,
Yeah.
Rod came up to Crested
Yeah, I
Butte a
know.
number of times when I was doing these events with Martin Fowler.
He was just, he's, there's no point in a good piece of software if there's no people. And it was just sort of, it's just so self-evident, and yet you have to work at it. It
Mhm.
sets the tone. So anyway, I love that about the Python community, and I love that it doesn't have all the cutting edge features. It doesn't have all the whiz bang new novelties. It's
That's
only
a
the thing.
surprising number, though.
Oh, but
I mean,
but it's slow. They're not quick to jump in there
No.
and do it.
no,
without
it's
proof.
not PHP.
No, or Scala even. I mean, Scala has every feature. It's just,
Mhm.
and sometimes it feels like a bit of a research bed.
It is.
Yeah.
It is. I mean, that is
Martin's
why,
practice.
I feel like, okay, Scala has done great things in terms of experimentation.
Right.
For example, what would happen if you could build you could overload, you could create your own operators to overload? What happens with that? It's like, okay, no other language will do that, because we learned from Scala that makes incomprehensible code. And the Python approach and the Kotlin approach and everything is like, we have a set of operators.
Yeah.
You can overload them. They have names, so you can search for them. All those things. It's like, okay, we did the experiment in Scala. That didn't work out. And Scala is experimenting in a lot of ways. There's a number of features that they have revised in further, because it was not comprehensible, didn't work out for some reason. So it's great for that. Whether you want to use it as your day-to-day language,
you could.
Some people do.
It's gotten a lot better now.
Bill does. My
Yeah.
co-author Bill, he uses it all the time, and James is a big fan. I'm moving more towards Python, but I've learned a huge amount from Scala and
I quite like
this
it.
other language.
I mean, okay, so what do you think of, because you wrote a book on Kotlin too, right? I mean, how'd you find that experience?
Oh, I find it far superior to Java for sure. I would. I mean, that's another reason I would hope that I never have to touch Java again, is because once you've used Kotlin, you go, oh yeah, they haven't solved. They solved like all the problems that they could.
Yeah.
While being easily. The thing about Scala was it was designed to work with Java. Yeah. But not easily. Sure. Whereas Kotlin is designed to seamlessly interact with Java. Mm-hmm. I mean, you have to deal with things like, the fact that any function can return null. Right. But it kind of puts a box around that. It says, oh, you're calling Java, so you have to deal with the null. Nullability. Yeah. You have to deal with the null. You can't just ignore it. You have to cope with it somehow. Yeah. And so it's the static typing is much better. Yeah. And so you get the best of all worlds, whereas Scala was again an experiment. Says, we can talk to Java, just not that easily. And Kotlin says, we need to be able to talk to it easily. Even there, though, I think Scala, like the annotations weren't the same thing before in Scala, and I think they have more converged, for example, and it's getting so they improve it. All the time. And Martin Odersky is a genius, and he was responsible for a lot of the important stuff in Java. So, like, if anybody's qualified to say, "Hey, this wasn't great," I can fix it. Like, we owe Martin that difference certainly. Sure. The jump from Scala 2 to 3, Dottie, was a little tumultuous. It kind of reminds me of another jump from 2 to 3. The Python one. Yeah. Although years ago, whatever it was. This was it's done now. I think we've all moved on, but but it was necessary. It was holding so many things back. Yeah. And the changes weren't that momentous. No, but they were parentheses. Who cares? It's fine. They were significant enough that it took a while the problem is all the libraries had to catch up. Yeah. And so it took a while for that to happen. I think what they did, because again, they're super pragmatic in the Python community. There's no ego here. They're just trying to make sure people can sleep at night knowing their software is going to run the way it's supposed to. So as a precautionary measure, they had that future import from future. Yeah. So you can proactively start. You could try things out. Right. And again, I think if they just cut over and said, hey, look, we're not going to give you years of previews and Mhm.
hang it over your head like this looming change that you'll have to. It just seemed like a mountain when it was more of a molehill.
Yeah.
It just
Yeah.
because it was so easy to think, well, this must be very dramatic if we're out doing all this prep work and we're talking about these things now. We have a package called future future
Mhm.
future, dunder future. Like I don't know, but of course that would have inflamed some people whose code really did need to do some major refactoring.
Yeah, the language was unable to move forward to do things like, I mean, like now we have the static type annotation.
Oh, type ins, yeah.
Yeah, which are, I mean, that's a whole nother change.
Yeah.
But it's huge.
It's
I mean,
nice,
yeah, I mean, the more I use strong static typing, and I wrote an article many years ago where I was arguing, I was going, oh, strong typing versus strong testing. It's like, oh, well, you just need more tests, and dynamic typing is fine. And it got quoted a lot, and I look back and go, I don't know. I guess I was justifying the situation the way it was, but the benefits you get from the static typing is like immediately you do something wrong, you get the red squiggle in your IDE, and it's like, why would you not do that? Why would you want to put off discovering a problem or having to write tests to discover the problem when you could know it as soon as you type the code?
Amazing. Yeah, I mean, and by the way, that feature, again, they're super pragmatic. There's no ego there.
Mhm.
Even the import from types versus typing,
Mhm.
they've done some reworking.
Mhm.
That even, I mean, and they have generics now, right?
Yes.
And elements, so you can have a
Mhm.
list of bracket, a
Yeah.
square bracket T or whatever.
Sure.
Like even that's it's getting better and better
Yeah.
day by day in new versions. So okay, Python 3.3. Are you still actively engaged in that community? Do you write Python code these days, or
Oh yeah.
do you? By the way, Emacs, VI, Visual Studio, IntelliJ. What do you use?
I've
PyCharm?
moved over to PyCharm, but I'm also experimenting now with Cursor.
Oh, the AI one.
Yeah, well,
Super
just
nice.
all of them, all of the AI ones, especially because I had always dragged my feet on writing tests.
Yeah.
And the AI systems, the tests aren't perfect, but they do so much for you.
Yeah.
And then you can, and the other thing is I learned so much because I go, all right, do this in a really smart way, in a compact way. And you go, oh, that's how you do that. And so I feel like it's really benefited. I mean, especially because we never seem to write enough tests because they're hard to write. And they take a lot of time. But with the AI tools, it's really helpful. So, and like PyCharm has a
AI assistant.
AI assistant.
Have you tried that? It's
yeah. I bought a year.
Yep.
So I'm experimenting with the different AI systems because they're super helpful.
Now, yeah, they are. And by the way, another question: do you just use regular old PyTest, which is in the SDK, or do you use some other library for testing?
Well, PyTest is actually an external library. There is the built-in library is.
Oh, sorry, yeah.
What is it? Unit test.
Yeah, that one.
Built-in library is unit test. I've experimented with both of them. I think PyTest produces more readable tests.
Yeah.
But I've also had friends argue that using the built-in unit test has its own benefits. It's often
batteries included.
It's batteries included. You don't have to argue about it.
Right.
And it tends to be maybe a little faster.
Yeah.
It's sometimes significantly
Less
faster.
setup to do because it's just there.
And but and for me, the readability and understandability is really important.
Yeah.
So I have tended towards PyTest.
I used to prefer, because one of the reasons I moved to Python or used Python was because I could just scratch something out quickly.
Solve something just like that.
Just like that. And the batteries are included for most like you want to do JSON, guess what? There's something in the SDK. You want to do testing, there's something in the SDK. You want to do talk to the HTTP services. You can do almost everything. You can't build your own HTTP service out of the box, not easily anyway. But if you just want to glue the things together, it was trivial. And so I was always inclined to use the embedded one. But now I just do pip env space init, and then do PyCharm space period, and I have myself a valid project, and I can do pip install PyTest, and it's like there's no overhead mentally anymore. It's
I've-
trivial to set up a project.
Yeah, I've been using Rye, and now there's UV, which is, and both of those are modeled after Rust's
Rust up.
cargo,
Oh yeah.
which because a year and a half ago or whatever, I fell into
Rust hole.
Rust hole, yes. And just, got to the point where I go, okay, I think I understand all the keywords now. Now, doesn't make me like an expert Rust programmer, but I can read it. And mostly I use the AI to generate things. Right. And then I study it and, test it and understand it and tweak it. But the experience of using Cargo will just ruin you.
Right.
Because it does it's like, well,
build, test, compile.
Why haven't we been doing this? Why? Because this stuff is second class citizen, I guess, always. But because of Rust, things like, some things have been being rewritten.
Right.
Python things have been being rewritten in Rust just for speed. But then also, I started using Rye, and it does all that stuff for you, and it manages everything, and it manages your virtual environments and all that kind of stuff. It's
I'll try it.
Okay, oh yeah. Well, and then
I use pip env, which does dependencies and virtual environments, and it gives you the metadata that you can use to get Python to give you a valid IDE installation.
Yeah, and this maintains your PyProject.toml for you.
Yeah.
And
nice.
It does everything that you need. But the thing that's kind of superseding it is this tool UV, and they've actually taken over the Rye project. And so they're maintaining it. And I think eventually the goal is to suck the Rye people into UV so that they only have one thing. But it does all of that stuff for you. And it's just like, once you do that, then you don't want to go back.
And this is very much in the Python spirit too, is that sort of like batteries included, everything just should work.
Mm-hmm.
One of the things I love about Python is the formatting. I know this is a hot take perhaps, but I quite like that there's just no room for disagreement here on how you format it.
If I'd have thought, I'd have brought my shirt, the t-shirt I have, which comes from, I gave a keynote at one of the really, really early Python conferences.
Right.
Before it was run by this third-party company that always charged a lot and always claimed that they were losing money, and then kept doing it. But anyway, so the first time I did that, I think I had dinner with Guido, and I was effusing about Python, and I said, life's better without braces. And so he later reached out. He says, can we use that for the t-shirt next year? I go, sure.
Yes.
And so I have the t-shirt, which is kind of fun, and I brought it with me. But and it's from 2000 or something, and it's kind of fun because this is actually me and Guido having dinner, and me going, and it's this cartoon with clearly the kid had braces, and they had taken them off, and he was like, oh, life's better without braces.
So good.
And so and then Scala 3 has the what is it, meaningful, I want to say meaningful indentation, but that's not the right phrase.
Okay.
Anyway, it has picked that up from Python, so you can do that, and we use that in the effect-oriented programming book because it just produces simpler, easier to read code.
And so the Go has Go format. Go as a tool that you can use to format your code exactly the same.
And Python is black.
Right.
Well, I think Go probably picked it up
from Python. Yeah.
From Python.
Because even without black, you have to, or your code won't run.
Well, yeah, it has to be indented properly,
Right.
but then there's all the other standard
new lines
formatting that and it's so ridiculous that we have fought about formatting for all these years.
Exactly.
And it's like, it just makes, when you realize if everybody's code looks the same, you're not spending part of your mental cycles trying to parse their formatting. It's like, no, it all looks the same. We can talk about it. We can, it's like, it's nuts.
My experience in the Python community and seeing that Go had this and all that has meant that now every project I start in Java, I install a plugin to do code formatting.
Right.
It'll break the build if you haven't run the formatter,
Yep.
the build breaks. So
Right.
it doesn't matter if you're using IntelliJ or Emacs or VI
Mhm.
or NeoVim or Eclipse or just a notepad, whatever. You can all contribute, but we all run the same formatter and there's no arguing.
I think going forward, it's just going to be, all the new people are going to go, what? What, you old fogies? Why were you arguing? Why were you wasting your time on this? Why? Yeah, well, tabs versus spaces. They're Go.
Yeah.
Yeah, Go kind of lost me there. It lost me in its import format. And then the more that I looked at the language, I go, okay, yeah, you have your return structure, but it's optional. You can just ignore it. And then, the concurrency model is so simple. Yeah, well, you know why it's so simple? It's because it doesn't really do anything for you.
Oh, yeah.
Yeah, I mean,
Go
you can
teams.
do all that, but you have to write all the code yourself, and then it's complicated.
Right.
So it's like, all right, if you're just writing these little tiny utilities and they run and then they end and then they clean themselves up, all right, yes, that's fine. But using it for an entire
Stateful
a
thing.
big project, no, you don't want to do. I don't think you want to do that.
So, I don't know that I don't, my prima facie sort of interactions with Go, I've never gone down the rabbit hole. It just didn't interest me. I never did. I know enough to know I don't want to do it.
Your intuition was correct, I believe. I've looked into it.
You're a student of these things.
Every time I learn something new about it, I go, yeah, I don't want to use this language. Hey,
Anyway.
if it makes some people happy, that's fine, but it's not for me or you.
Go for it. Whatever. Okay, so fast forward. Let's get it because I'm leery of your talks in 20 minutes or something like that, right? 2:15.
James is giving a talk. Yeah.
At 2:15.
Yes.
Okay, so we got
That's
it.
right.
So now you've got thinking in Java long since in the rearview mirror. You did Atomic. No, not Atomic. You did another book on Java.
Oh,
a decade ago.
No, it wasn't that long ago. It was actually only a few years ago. On Java 8.
On Java 8, yeah, that one.
Yeah, which I'm that was the guy who suggested I use that title was Eric Evans, the domain-driven design guy.
Yeah.
Yeah. And because I've known Eric for quite a while.
Oh wow.
He suggested that, but anytime you pin something, it's like it's got its pluses and it's got its minuses. So, but there's a lot of people who are still moving to Java 8. And so a lot of those things are new and different to them. But I did that. It was a few years ago.
2017.
Oh, okay.
Someone in the audience.
You have. Oh, thank you.
Thank you.
That sounds about right. Pre-pandemic, so
BC.
It's like it's like back then. And that's you can get that on LeanPub, and one of these days I might do some. Just take the 4th edition of Thinking in Java, put it up on LeanPub, just to make it, available for people. I wouldn't change anything though. I don't want to rewrite it.
I would buy again. I've got.
Okay. Well,
sign me up. I would, because what I want more than anything is a freaking Kindle version of it, so I can read it in my app.
Okay. Okay. Well, point taken. It's on my to-do list. It's just like, it's a project. It probably won't take that long.
No.
But
you have Amazon Kindle Direct Publishing, KDP.
Well, LeanPub puts it out in a version that will go onto the Kindle. So.
Oh, I know. So I use LeanPub for my last book, right? For the early access experience, right?
Mm-hmm.
But then by far the largest revenue from that book came from them taking the finished thing once it was done. My pipeline dumped out a Kindle. Yeah, put it on Amazon Kindle Direct Publishing. And then they can do a couple things. Well, so you put it on Amazon first.
Mm-hmm.
That's huge already, huge market for you. But then there's another group of people that really want the printed one. And so Amazon KDP, they can do print on demand.
Well, the printed one is still available on Amazon. That one's already there. But this was before anyone thought that ebooks were going to be a thing. So I retained the rights, the electronic rights, but I just haven't.
Well, I would
them. Okay.
Happily pay.
Noted. If there's a demand out there, I will. That will.
It doesn't hurt. You don't lose anything by putting it out there.
No, I don't. It's just it's a project.
Yeah.
So but it shouldn't be a big project, I don't think.
Okay. So I'm a huge fan. So that was the on Java 8. Then was that after Atomic Scala, or before? You've had
It was
quite
after Atomic Scala.
And then when was the Kotlin book?
Was after the Java 8 book. Yeah.
A lot of very busy guy for.
They'll take a while.
Yeah.
So yeah.
And now we get to, so you've got this incredible, like, it's just nice to see you back on the JVM. Honestly, by the way, did you ever write a book on Python? Actually, I don't even know.
I have tried numerous times, but my next book will be, it will use Python.
I think that's the language
Yes.
to which you've had the most sustained contact, or with which you've had the most sustained investment.
It's
And yet no book.
crazy. I know. I made a number of attempts. There's one that's kind of out there. Oh, this is a bad story. Is kind of out. I did something where I took something and I started translating it into Python, and I think it was called Thinking in Python. And I think if you hunt for it, you can find some version of it.
Right.
So I put it up there, and it did not understand Git at the time, but I put it up on GitHub or no,
Yeah.
I don't think it was GitHub. It
Get
was
that maybe.
it was the other one that I don't think anybody's using anymore. But I started getting these things called pull requests.
Oh no.
And I'm thinking, why are you requesting to pull my thing? Just pull it. Don't ask me. I did not understand. And so after a while, people started going, he's not incorporating our pull requests, because I didn't know what they were. And so that kind of, I could have had a lot of
Communal
support,
Yeah.
and I was getting it, but I just didn't understand GitHub well enough. And so, I think there's even a cover, which is a painting that I did, kind of a watercolor painting with anyway, I think people can find it if they hunt around, but it's like not complete, and
It's Python 2 of it too, right? Or
probably, yeah, I don't.
That market, I mean, it's not like Python's all that difficult to grok if you have any programming experience at all, but nonetheless, I think that market, your touch would be particularly
Well,
appreciated.
it needs to be something that, I mean, there's so many good basic books, and there's some good intermediate books, like my
Yeah.
friend Luciano Ramallo created, can't remember the name of the book, but I mean, it's really a good, like, intermediate level
Yeah.
book, and it goes into things, it's like, if I were to write, the equivalent of Thinking in C++ or Thinking in Java
Right.
for Python, it would be Luciano's book. So I don't need to write that. But I'm looking at something, it's like the thing that I'm looking at is, did somebody find it?
The Thinking in Python.
Oh,
PDF.
they found the link.
Yeah.
Okay, yeah.
Do you want me to promote that, or do you care if people download it?
The thing is, it's not. It's like half finished or whatever. It's not really.
So is that a dead end?
I'd say it's a
Okay.
dead end. Yeah, I haven't touched it for so long. And what I want to do is, and this, even though we just finished effect-oriented
Right.
programming, this other book originally it was going to be concurrency.
Right.
And then I finally realized, nope, concurrency is too hard. I have to give up.
Right.
I spent a lot of time trying to, work through it. And it's been decades on and off. I've dipped in and out of concurrency. I thought, okay, now I'm going to solve that problem.
Sure.
Nope, not going to solve it. It's too hard. But what I realized in the process is there are all these things that I have learned, and I've been speaking at the Python conference for
Right.
a bunch of years, and especially like during the last 10 years, a number of my presentations, I realized each one of them is solving a problem that if you incorporate this practice, it will make your programs more resilient. I got this phrase in my head: stubborn resilience. That's what you want. You create a module and you try and push it in the wrong direction, and it just pushes back.
Yeah.
And so it's the kind of thing that if you incorporate this into your programming, your whole system is going to be stubbornly resilient. And so these are the techniques that I want to teach, and that's something at least I haven't seen done. And so this book just keeps coming, festering, trying to drill a hole in me. Anyway, so that is my
I would
next
love
project.
to read that.
Yeah, well, I am really looking forward to writing it, and I am in the midst of working on the introductory chapter now, just kind of saying, okay, the problem is that software projects have a miserable success rate. They're almost, this book that I read, which I highly recommend, is called How Big Things Get Done.
Yeah.
And it's a very scientific, very, not, so many business books are just
Platitudes.
bovine excrement and made up stuff, which they like to call management science, but there's no real science. It's management making stuff up.
Okay.
This is the world we live in, and there's only so much you can do with that part, but there are these things that you can do as a programmer to increase the possibility of success.
This is the book I want to read.
Yeah.
If it's from you, I would
too.
read this.
I want to read it. I want to read it too. I want to write. I mean, it's just, I'm really looking forward to writing this. Yeah.
Well, now, just for the audience, those of us who are waiting with bated breath, can you tell us when we can expect to see Thinking in Enterprise Java finished? No.
Yes, I learned that you can get enthusiastic about something. You can go, oh, this is the next book I'm going to write. And then you might discover, well, as you well know, that Enterprise Java was
a little painful.
Yeah, I mean, not even really. It took me years to even understand what is enterprise programming anyway.
Yeah.
It's like, and I finally realized, oh, it's customizing solutions for a particular enterprise. So you try and get as much of the common components, but there's always this significant amount of customization. Oh, that's enterprise programming. Okay. And then the way that EJBs did it, that was an ivory tower project. And of course, we needed something like Spring to come along and make it palatable.
So the emperor has no clothes.
Yes. Well, and I didn't know, once again, Sun was pushing these things. Oh, they're smart. They know what they're talking about. And it turns out, nope.
Well, sometimes they do. I
agree.
Sometimes
they do.
I don't want to discredit Sun, but
no.
But
you just, it's like AI. It spits out all this stuff at you, and you go, no, I got to test everything.
Yeah.
I can't trust it just because the company or the AI or whatever it might be useful, sure, but you can't trust it. It could be delusional, and Enterprise Java beans were delusional. Boy, did they put a lot of money into it.
Yeah.
And a lot of people lost a lot of money.
Yeah.
Trying to build systems using that.
It
was just somebody's idea.
Yeah. We could do a whole thing on that. I want to get to if I want to build a reliable system today, then I think if there's been a through line for our whole conversation, it's that concurrency is going to cause trouble, distributed state is going to cause trouble, parallelism is going to cause trouble, right? These and especially the layering of abstractions that hides from you the critical state management underneath the hood, that can cause trouble.
And what problem are you trying to solve? Really understand your problem domain before you jump in and start coding.
So I think there's a need for people who are trying to build these stubbornly resilient systems.
Mm-hmm.
I think a big part of that is having clarity around state transitions in the system, and so I think there's a lot of appeal for projects like ZIO, which Zio they guard that. So it's not a foot gun, right? There's well delineated ways to make changes in the system, and is that kind of what your new book's about?
Well, yeah, the book that I wrote with Bill and James.
Bill Fraser and James Ward.
Yes, right. And we've worked on it for 4 years, and we talked about it before then. And I mean, it's like we're not even sure exactly when we started it, because it's that was a long struggle. And simply to understand what problem this effect systems are trying to solve. And it's a different way of thinking about programming, because what we have traditionally done is said, all right, let's write the program, and look, there's some problems, there's some prizes. Well, let's write some code around that to try and pat. You're basically in a submarine and it's springing leaks and you're patching holes. And so instead, the idea is to go, well, where are these leaks coming from? Let's look at it rather than just go, leaks happen, you got to patch them,
Right.
which is what we've always done. So the idea is to say, and ultimately we're trying to, all we've ever done in software development is try to compose things. We try and take little pieces and make bigger pieces.
Sure.
And scaling is what shows you, well, like what we were talking about with concurrency.
Right.
Oh yeah, you can write these little interrupt service routines, you can write these little things,
Right.
and you can make them tight. But that doesn't mean that that concept scales up, and it doesn't. And so that's the thing that we run into. We go, well, we want to build a bigger system. Let's build it out of these small parts.
These
If the
atoms.
small parts have little flaws in them, then those flaws are going to be amplified as you put them together.
Yeah.
So what an effect system is trying to do is saying, well, let's look at the flaws and let's look at the problem of composition. And how do we make that a seamless thing? What needs to happen? And the ultimate issue is basically unpredictabilities or surprises. Like, oh, this thing throws an exception, and do we have any way to know what that exception is? And exception specifications. And it turns out that didn't work.
No.
C++ actually, in its more recent versions, they threw away the concept of exception specifications, and they use the functional way of doing things. And so Java, of course, still has exception specifications. But if you look at that, that's a shadow type system.
Yeah.
And it really needs to be in the main type system. And so that's what the functional approach does, is it says, okay, everything needs to be part of the type, part of the
data.
return type of the of whatever function you're calling.
Yeah.
And so that and all these other things that are unpredictable need to be packaged in that return type. So whoever is trying to call that function knows everything about it.
Right.
All of the unpredictable aspects and all of the error conditions and everything. And so then once you do that, then you can reliably plug components together,
right,
because you know everything about it. Whereas the way it is now, it's like, well, look at the source code. Maybe you've got a divide by zero happening. And
well, and also that's it. The thing with the exceptions is that you can kick the can down the road by just redeclaring that. And so you get so far removed from the site where the actual problem that occurs that you're impotent to be able to do anything about it. Whereas with the errors as data paradigm, you've got it right then and there. It's
right.
You have to deal with it.
Well, and the other thing about the problem with exceptions is that somebody could change the code, you get the new version,
right,
but there's no evidence that you're throwing a new exception. And so all of your code, which is based, even if you did dive in and look at everything, it's based on what you saw before. The type system isn't able to detect the new situation, and so now your code is broken, but you have no evidence of that, and so it doesn't work.
So I want to talk about exceptions, but effect-oriented
programming.com,
and it's available on.
If you go to the website, that website tells you where to get it from. You can get the ebook. Yeah, effect-oriented-programming.com. Yeah, so that'll take you to our website.
Daniel Harris with the amazing art again.
Yeah.
Hello from Serbia. Hello from Brazil.
Oh, sweet.
We got people chiming in to see.
Okay, yeah. So so that's the URL, and I think there's
check it out, everybody.
And so you can get it in print, or you can get it in as an ebook.
I will buy the ebook, but people, you can all be jealous of me.
But we gave you the print.
You gave me a print one, and it's signed, and I'm not going to touch it because I don't want to I'm going to frame it,
Oh, nice.
I got a signed version.
Okay.
Okay. So that book, thank you for this book. That's going to be a great read. And so, by the way, it's not a very big book. It's
we peaked at 300, and then we cut it back to 150 pages.
It's a great size.
We wanted to I mean, there's so many intimidating things in functional programming, and
Yeah.
we don't want to be another intimidating book. So we did a whole bunch of things to make it simple so that you know what the problem you're trying to solve.
Right.
Rather than going, well, first you have to know category theory and monads. There's no, those
say the M word?
words, those words do not exist in the book. So yeah, because we know what it's like. I mean, I have tried to read a lot of functional programming books, and
Yeah.
I know what it's like to be just overwhelmed. And
If
and
you feel
not-
again, if you feel overwhelmed, then what the hell
Well,
do the rest of us have?
but I'm not somebody who picks things up instantly. I take a lot. The reason that I think I'm able to explain things is because I remember every pain point
Right.
of trying to learn something, and it doesn't come easily to me. And so I'm able to kind of lay it out for the people who it also doesn't come easily for.
You do a great job.
Thank you.
One of the things you've articulated from the very beginning was, so going back very quickly here, because we are
Mm-hmm.
fast running out of time.
Mm-hmm.
One of the things you mentioned checked exceptions, right? We talked about exceptions, and you've always been sort of like, why? Why do we have these?
I struggled with them because the first time I saw exceptions at all was when they were introduced into C++.
Yeah.
And then I had done a lot of research to try and understand them, went back and looked at Barbara Liskoff's initial early papers on them, which are not on the internet. And, just tried to figure this out and, why does it work? Why does it not work? It's taken me a long time to understand, okay, here's why this is a problem.
Yeah.
And then we have, the checked versus unchecked. And yeah, when you look at the problems of error handling, like the biggest distinction is this an error that you could recover from, or is this a panic?
Yeah.
One of the nice things about Rust is that it makes this very clear. Is they go, oh, that's a panic. You can't do anything about a panic. Maybe you can log it, but
Sure.
but you have to stop.
Right.
And then there's these other things where it's like, oh, you might be able to recover from that. And the problem with exceptions is it sort of makes that distinction
Right.
using checked and unchecked exceptions, but it's not. You really need that distinction between a panic and an exception, or however you're going to report your errors.
And there's no force of law or anything. It's like there's nothing stopping me from making an innocuous exception that is more about control flow, a checked one,
Mm-hmm.
and making a one that is actually the end of the system. It's debilitating and cataclysmic, an unchecked one. It's just
Mm-hmm.
the language lets you do it. Anyway, that insight guided Spring as well, right? We make it so that you don't have to muddy your code. All of our callback methods, most of the time they throw exception. And so you can just write the code. If there's going to be exception, it'll bump up to the framework and we'll handle it for you as best we can. But you don't have to, your code is not constantly doing try catch everywhere, right? You don't want to
But you could if you wanted
Of
to
course.
at a lower
Oh, yeah.
level. But you're saying, okay, the framework, we're going to build as much of the resilience in, so
Right.
you don't have to be thinking about it every time you build
Yeah.
the simplest little system.
because exactly. Yeah. And I just think that was it's one of those things where it's just such a small thing, but it was kind of heresy to suggest it 25 odd years ago when you first started carrying that torch, but yeah, it's just such a great obvious thing today. And anyway, thank you.
Sure.
Everybody, we gotta go. We got to talk. We gotta go. Is it your talk or is it just
No, I'm going to see, James is talking about kind of the basics of functional programming.
Okay.
And I need to see that to see how people are accepting it. So when we give our talk tomorrow, we'll be able to gauge,
Where to start and what
where
not
the
to do.
audience is. Yeah.
Okay. What a great show. Dev 2 Next in Colorado. You're in
Uh-huh.
Colorado.
So, yeah.
Beautiful state, amazing tech community.
Uh-huh.
Come to the show next year. This
Yeah.
is worth it. I'm everybody great's here. Thank you, Bruce.
Well,
Appreciate you.
This
Thank
is
you.
a lovely interview. Thank you.
Bye, everybody. See you around. I'll do more live streams. So,